Hi, in this lesson, we'll look at stacks. Let's get started. In this lesson, you're going to explore one of our first new data structures, the stack. Stacks are built like a vector in that they store a list of items, but unlike a vector, you only have access to the top of the stack. You can think of a stack like a stack of books. Every time you add to the pile gets bigger, but you can only access the top book. As a result, stacks are a last-in, first-out data structure. The last item you put in a stack is the first item you take out. A stack is a part of a standard library, but it still needs to be included. This is how you include it. Stacks can be declared as an empty stack with a variable type, similar to how a new vector is declared. Once declared, they are empty, but are ready to be added to whenever you want. This right here creates a new int stack. This one will create a new string stack. They're both empty, but you can add to them. While we will not explore it in this course, stacks can also be declared and initialized with an existing data structure, such as a vector. You might be asking yourself, well, how do I add to a stack? Well, the push function allows you to do this. It inserts a new element at the top of the stack. Go ahead and take a look at all the other basic stack operations. Pause this video if you need to. There are a couple of things to notice when looking at stack functions. First, unlike other languages, C++ separates access and remove functions. If you want the top item in a stack, you will need to use the top command, but the item will remain on the top of the stack. To remove an item, you use the pop command, but this doesn't return any value. Oftentimes, you may want to see and remove the item. Many languages have a single command for this, but in C++, you need to use both the top, then the pop commands. Also, you will notice that there's a size and an empty function. While it is possible to use size == 0, this can be streamlined with an empty function. If you're asking yourself, how do I iterate through a stack? The answer is, you don't. Stacks have a very specific purpose and limited functionality that only allows access to the top value. If you need functionality to see different items and lists, then you should not be using a stack. Let's look at an example for basic stack operations. As you can see here, we added 1, 2, and 3, and at the top is 3. Then we take off a number using the pop method, and the new top is 2. Then we use the boolean empty, and it returns 0, meaning that there is still 2 left in there, as shown by the size function. Let's walk through another example. Here we are pushing letters into a stack. After looping through the entire phrase and putting the letters in a stack, we then use a while loop to remove the letters. Suppose the user entered the word hat. Our for loop will loop 3 times. First the H, then the A, and then finally the T. Here's what our stack would look like after each iteration. Each time, the previous letter is pushed farther down. In the stack, we only have access to the letter on the top. So as we move through the stack in our while loop, we remove the letters in reverse order. Notice how we access each letter in the stack with the top command and then remove the letter with the pop command. Once removed, this letter is lost, so there's no way to loop through and view each letter without removing it entirely from the stack. Now that you've learned about stacks, let's get some practice using it in the CodeHS editor.